So the reason that we might be able to get through 3 lessons is I've over-taught you this entire time things about triangles and trigonometry and everything else. So at this point, you're like, I know this. Why are we learning it? I know it. And that's how we're going to speed through these lessons. So what is Darren essentially going to create to make his life easier and justify why A is 1, which we've already shouted out?
Make it equilateral.
Yeah, equilateral triangle, right? So his teammate Jan comes up and says, so if we draw this out here, we have a 60-60-60 equilateral triangle, which then means that 2 times the A is 2. Well, okay, so then that means that A must be 1. And then how do we figure out B? Yeah, we can work the Pythagorean theorem backwards since we know that that exists. Is there another way? We didn't know.
Yeah, just like that. Take 1 square root 3, something like that. I don't know.
It's radical 3 over hypotenuse. This long side. Oh, it's radical 3 over 2. Sorry, I was wrong.
There's a radical 3 involved, but compared to what? We might need to pull out a calculator and double check this Pythagorean.
Is it just radical 3?
Well, we know B is longer than A.
No, it's I'm right.
B's shorter than C.
I'm right. Because it's x radical 3.
So here's the thing. Grab a sheet of graph paper because we've never actually written this down yet.
I've written it down.
That's a highlighter.
I writ this down at some point.
You writ this
I
down?
writ it down.
Writ it?
I just forgot if it was A or B that was radical 3.
I wrote it down too because
I thought it was.
Well, obviously you didn't write it enough to retain it.
I did, but then Jake said something wrong, and then it was like,
Radical
no.
3 times A.
I was right.
Okay,
So-
it's just radical 3.
In your 30, 60, 90,
I've written it multiple times.
Someone left their pencil box.
Put it in the loss.
It's mine now.
Okay.
so if we set it up like this, we're going to say that our height, our altitude, whatever you want to call it, is radical 3 times A, and A is always,
1/2 C.
yeah, A is always 1/2 C.
I wrote that down.
I just wrote the picture.
So the tricky part comes in when you aren't given C,
I wrote it down at some point.
when you aren't given C to reference, right? Because then we got to play with things a little bit and fix it so that we can actually relate things like we're used to.
A to reference, then it's easier.
Well, so if we're given A to reference, what would we say then?
So we just do radical 3 times A and 2.
So if given, so then hypotenuse, or C, I guess, well, I'm just going to write hypotenuse.
2A.
Hypotenuse is 2A. Okay.
Yeah, so it's easier even if we're given a short leg. But if
How do
we're
we
given a
remember-
long leg.
How do we remember the radical 3?
There are 3 sides of a triangle.
Yeah, but there are 3 sides to every triangle.
The 90 and the 30.
They're all multiples of 3.
I remember.
Now,
it
so
was-
is the 45-45, but it doesn't look as nice.
They're not. If you take away the zeros, they're still multiple.
Ah, there we go.
Well,
So,
I guess-
what if instead of having a hypotenuse of 2, which is nice and easier, what if we have like hypotenuse of 8? What would y be here?
4.
And
then
x would be?
equal 4 radical 30.
4 radical 3 is the simplest way that we write that.
Radical 3, dude.
What if we're given the A, though?
Then
Then we got
m is
30.
30.
And radical 3.
15 radical 3.
15 radical 3.
Simple. No,
Excuse me, what's our height here?
Is it a
3
30
radical
minus
3.
60 minus
3.
90 triangle?
No, wait.
No. 3.5. That's only true if they rounded to 3.
Wait, we don't know because it doesn't say 30.
Oh, we do know.
We do know?
We know it's
Oh yeah, you could use like science.
We know.
Hold on, pause. Take a moment. What do we know? They just both said, oh, it's not.
No, it could be. I agree. No, it could be.
We don't round unless it's absolutely necessary.
So the one side that's not measured could be 3.5. But then it wouldn't be 3.
Wait, we could just do
3.5 times
Pythagorean
radical 3
theorem.
is 9.
3.5
3.5 times radical
Is this a 30, 60, 90?
That's the question.
No. So, regardless of solving this, like, I can Pythagorean to solve that side, but this is not a special triangle, right?
You're
because
not special.
there's nothing special about you. Okay, maybe there is. It has a prime number. It has 2 prime numbers already. All right, so 45 45s we know is a what type of right triangle? Isosceles.
Yeah.
But how does that hypotenuse relate to the legs?
X radical 2.
Radical 2 times that base leg. A, or whatever we're going to call it. So then down here,
It would be 20 for the other leg.
20
Radical
And
2.
20 radical 2.
and 20 rad 2.
Right.
And then 5 for the other leg. And then 5 radical 2.
Do you really need to specify the other leg?
It's so simple.
You messed up on the other one now after you said it was simple, sir.
No calculators.
Oh.
Take a moment.
No.
Take a moment on your own. Like, just jot these down. I don't care if you draw pictures of them. Just jot down what the unknown leg lengths are to catch any mistakes you might be like primed to make. All right, so you guys have to tell me if this idea I have is decent. You know how we're like continually trying to build community and stuff like that.
Are we?
I'm thinking of whether it's holiday themed or not, but I think the first one might be holiday themed. I'm thinking of creating a giant Tetris board, like on the wall,
Holding on to pieces.
and then each person could take a piece and decorate it, whatever, and then put it on the Tetris board.
So like what Perry did, like with all those like.
No, not what Perry did,
But why
because
does
this
he
is going to be geometric,
What if we just
and I'm
draw-
teaching transformations
Wait,
right now,
but
but
what
I'm recording, so.
What happens though if it makes a line? Does it all
Nothing. I'm trying to decide what happens if we make a line all the way across. I might, like, I don't know, those kids get
Every
something.
line,
or-
you give everyone one free pencil.
I already do that on the daily, because none of our kids can keep track of pencils.
I can.
Alright, I doubt it'll take 5 minutes. But let's solve these unknowns.
Wait, are we supposed to find
Any unknown legs.
But what about the angles?
We already know. Well,
You don't care about the end.
they're unknown, but they're known. Quote
They're
unquote.
known unknowns.
They're known unknowns, yes.
Ah, he's a trivial one.
Just like the provable, unprovable.
Why do you make
Proof.
these so tricky? It's tripping me out.
That's a tricky trick.
Wait, oh, no, it's really tripping me out.
Which one?
Oh, we got the long leg. That's.
No, we got the short leg.
No, we didn't. The short leg is always on the 60 side.
Oh, yeah, you're right.
The short leg is always on.
It's always
Wait,
on
do you
the-
mean opposite
It's
or
always-
adjacent?
It's always adjacent. To 60.
Ah, so the long leg is always adjacent to the 60.
No, the short leg.
The long leg's always corresponding.
The short leg is adjacent to the... Oh, because it's the hinge theorem. Ah.
Yeah.
That thing you're so obsessed with.
Hey, because I don't like talking in adjacents. I like talking in opposites. So what we're defending or saying or whatever you want to call it is that this leg is going to be shorter because the hinge is open smaller.
Correct.
So 9 equals.
That one's not that hard. Division. I love it.
I knew that was coming.
So wait, it's just long leg divided by radical 3 equals short leg.
I don't know.
You do know.
No. Really? He knows it? He said he didn't know it though. I don't
Yeah,
know how
teachers
he could
always tell the
teach us
truth.
a lesson if he knew the answer. That would just be silly. Okay.
Okay, fine.
You need to find a box that is a perfect cube.
A perfect
I mean, it's like this.
You're not
Mark.
gonna
I'm
find
debating
one.
just using this, but because I'm teaching area and all, this is a cube. Yeah,
Is it actually? Like,
yeah, but I kind of wanted to card because you see all my cardboard things. We're learning about variables and like terms right now.
Wait, what's the different? Why do you have one up there that is X? Wait, that's not even
Because
X.
here, X is bigger. Yeah, it's X squared. It just folds.
Oh, okay, I see.
Alright, so this base leg here.
20.
Ah, that's the nice relationship. And then the hypotenuse. 10 rad 3.
Wait, I think. No, wait. No, it's wrong. It's 20 and 10 radical 3. The other way around.
Oh, yeah.
Ah, 20 is bigger than 10 radical 3. We got to make sure that we keep these things where they're supposed to be. The altitude, or I guess we could say the leg adjacent to the short leg, that involves the radical 3.
The long leg?
That's what you just said. You switched those.
Yeah, no, it is the long leg. But I'm saying,
And
why
hypotenuse
you gotta
is
call
double.
it the leg adjacent to the short leg? Why not just call it the long leg?
Well, I guess both legs are adjacent to the short leg, so you're right.
Well, the hypotenuse isn't a leg.
I just said you're. Well, yeah, they are.
They are?
Let's
I mean,
go.
They're
They're
all
all
legs?
legs.
That's really no.
That's nuts.
We're just not gonna acknowledge that.
So then here is.
That doesn't exist. It's not real.
8, 8. 8, 8. 8, 8. This one was tricky because first off there's the confusing stuff, and then it's also drawn like a
Drawn wrong.
45 degree one.
Drawn wrong, absolutely. So, wait, let's start with easier, I guess. What's the hypotenuse?
Wait,
We don't know it.
Ah, we can't figure it out quite yet.
it's 18 radical 3.
So wait, this?
The hypotenuse is 18 radical 3. That's 9 over, or no, 18 over radical 3, sorry. That's 9 over radical 3. You just divide by radical 3 instead of multiplying by it.
So wait, this
9 over radical 3.
this is 9 over radical 3 because instead of going from the short leg to the long leg, when we multiply by radical 3, we're going from the long leg to the short leg, so we reverse the process and divide by radical 3.
And then you just multiply that by 2, so you get 18 over radical 3.
And then because the hypotenuse is double the short leg, it's 18 over radical 3. Yeah, that one was tricky.
3,
Alan said
Here?
3, 3,
Here?
3 radical 3.
3 radical 3, 3, 3, 3 radical.
So my legs that are like on the 90 degree are always going to share this common value.
The constant.
Like 9 divided by radical 3. 3 times radical 3. Right? Like 10 radical 3. Right? So we're going to share that value whether we're multiplying or dividing with it. And here?
6 over radical 2. And the other one,
Ah,
believe it or
same
not,
situation we just saw.
is 6
So
over
we have to
radical 2.
divide.
I know, so insane. That there's this
How are we feeling?
Goodness.
Feeling good?
terrible.
In the neighborhood?
But that has nothing to do with math.
I'm sorry.
Is that a song?
And we're done
It sounds like a
No, we're not. We're trying to do 3 lessons.
with that lesson.
For your homework.
Oh, wait, I
The
need to go.
problems I care about.
So
Yeah,
then
this
you
one's
go-
gonna be real quick.
Is it just the first one?
No. 6, it's super fast. 8, 10, 11. So really 6, 8, 10, 11. 6, 8, 10, 11. Cool? 6, 8, 10, 11.
Pythagorean triples.
Hey
What are
guys,
the other two?
why didn't the photon pack a suitcase?
I'm not gonna answer that. I feel like it's gonna be bad.
It's gonna be bad.
I don't know, Mr. Hudson. Why didn't the photon pack a suitcase?
Because he was traveling light.
It's not even math.
But it's science.
Yeah.
And it's a bad jokes.
It's a very bad.
Pythagorean
Oh, I
triples.
just got it.
Get it? Because a photon is light particles.
Yeah. Light? The physics of light is really weird.
My 7th graders totally did not get that joke. And I was like, those of us who are smart enough to get this will get it. Those of us who aren't will get educated. Because then I had to teach them what a photon was.
Educated.
Oh wait, 1A won! Oh my god.
1A finally got their first victory. You are correct. Right before break. And tomorrow we will figure out who the next winner is. It's looking okay for 1A. They're...
Who do you want to win? 1A or 3A?
I bet last year he wanted 3B to win because Math 8 was like...
Well, now 3A is my Math 8 class.
Oh, it is?
It's arguably easier for them to complete their homework because they
Get less?
know
It's like review things.
There are less of them?
they tend to like math more. You know what I mean? The kids who are in Math 8 because they are like accelerated a year.
Math 8's accelerated. I was
Yeah.
like, sorry, when you said Math 8,
Oh,
I thought
yeah,
for
I
us
guess-
Math 8.
No, I guess you guys
Math
teach-
8 is the
you guys do Math 8
non-accelerated
too.
class.
So, Pythagorean triples. What is it?
Oh, triple. Oh, three, like, whole
3, 4,
number.
5.
Yeah, this goes back to more math history, right? Which is my favorite part of my job, is getting to teach you guys some of the history behind this stuff. Especially you guys, because you're like my favorite class to teach. But I didn't say that.
You say that
I feel like you said that, like,
You said that
most
multiple
I've
times.
never said that. I didn't say it
Okay,
just
yeah.
now. I've never said that.
Not on a recording that's
Definitely not recording anywhere.
30
So-
seconds long.
The Pythagoreans, as we talked about yesterday, or as we watched on the video yesterday, were all about just nice numbers. They didn't even really like rational numbers, although eventually they decided to use ratios to discuss one number compared to another. But they still weren't really using them like fractions, right? Like, they would say 1 compared to 2, but they probably wouldn't say 1/2 because they didn't really like partial values. And, like, I'm not sure, right? Some of this is a tiny bit of a stretch. But Pythagorean triples are whole number values because they did not like decimals. Actually, that would then drive the question of, did decimals even exist yet?
No.
I mean, okay, it's kind of rude towards decimals, but it's not necessarily wrong.
I'm sorry. It's just,
I know, it's extremely distracting. We should open this door and see if my recording picks it up. It's 6th grade.
6th grade? Oh, it's
Hey, try to solve those unknown links.
It's the Perry kid. It's the Perry kid.
I mean, all it really takes is 1 or 2 immature and loud kids. It's not all of them, guys. Like, we gotta stop generalizing.
Just write 'em on the board.
That's why I said it.
Yeah, if you guys want to come up.
Yay.
It's been so long since we wow.
It's been like a week, but okay.
It felt so long.
Jake, can you move?
That was a terrible 3. Your 6s were phenomenal. And then, oh god.
Wait, you called his 6s phenomenal?
No, but look at that bottom 6. Like, the first 6
I
that
wonder
you
what
wrote
it is,
is like,
Jake.
Yeah, I know what it is.
Wait, oh. Yeah, never mind. I got it wrong. Okay,
You
yeah.
suck.
I just multiplied 4 and 3.
Oh, well, this is just.
Say more words.
Yeah.
this is just.
Why?
Because it's a dilation of that one.
Yeah, it's a dilation of the 3, 4, 5.
Ah!
Now move, Jake. I can't see the board. Thank you.
You guys know you have textbooks, right?
Yeah, but then.
They're all the way over there!
I mean, you're not wrong. How'd you figure out 13?
Because it's
Because
a part
1/6 square root
13
169.
triangle triple.
Oh, because we can do 5 squared plus 12 squared, and then 169 is a perfect square.
Exactly.
Correct.
I thought you were just going to say, because we already learned Pythagorean triples. That's what I was waiting for the answer to be. Like, I literally
I've seen
expected
this one
that.
before. I forgot about the 4 and the 3. I had seen them before, but I forgot it was 5. But
So
the 5 is
3,
12.
4, 5 is the smallest Pythagorean triple. And it's been used for millennia.
But what
like-
about 2, 1.5, 2.5?
It's not a Pythagorean triple.
Oh,
Pythagorean
because
triples
it's
use
not-
whole numbers. Because remember,
Yeah.
it's whatever unit we want it to be. But it's 3 of those units, 4 of those units, and 5 of those units. So if you talk about 1.5, 2, and 2.5, you're really talking about 3, 4, 5. Right? Like, because it's just a dilation of it.
And the D is the units are 2.
And the D is the dilated, D dilated, It's the dilated version of the 3, 4, 5 scaled up.
12,
The
let's say.
next nicest, or the next nice Pythagorean triple starts with a short leg of 5, and it's 5, 12, and 13.
That
Isn't
one
there another
works
one?
better if
7,
you're trying to
24,
make like
25, or something? I don't know.
Ooh, what we're going to do is continue to look for a couple more. So, how could we derive? So, like, the Babylonians had that tablet that had, like, hundreds of Pythagorean triples written on them. We should hypothetically be smarter than them because we have more technology. I mean, not smarter, but we got more
We should
more
be able to
tools,
program
right?
a computer to do it.
We should be able to. So, but we would have to know
like
what.
not us, but like someone's.
Oh no, us. So if we were going to program something,
I would love you to program a computer.
how?
I don't know how.
So we're
That's
saying
the point.
A and B and C all have to be whole numbers.
Yeah.
We should make a graph. Wait, a 3-dimensional graph.
So what if? So hold on. Let's make a little table.
Okay.
A and B and C.
Why do they have to be A, B, and C?
Because we're just used to saying A, B, and C.
Why can't we say like?
With like the model that Tony Stark has when he figures out that time is a Mobius strip.
I love that moment in that movie. Because I was like, Mobius strip! And everyone's like, shut up!
I'm totally Wait, did you actually say that?
I'm just going to leave that question unanswered.
Wait, really?
So yes.
Oh my god, you're a nerd.
Wow.
I guess you're
See,
mad.
when I think I'm turning to my wife to say something, I'm really yelling it to the entire... I'm like, that's a Mobius strip! You nerd! So wait.
That one
So
added
C is the square root of A squared plus B squared. And we said that's how we figured this out, because we knew that 169 was a perfect square.
we could just
This
put it off for
was a 25. So wait, we could think about perfect squares, but what would they have to... The C perfect square would need to be what?
The sum of the B. It's Pythagorean theorem.
Wow, really?
Yeah, but you can't define a word with the word. Like,
Exactly.
so we're trying to create a system to find more Pythagorean
So
triples.
you could do a perfect square plus a perfect square, I guess.
Right.
And then whatever that equals.
Has to be a perfect square.
So we need to find more perfect squares that can be broken up into the sum of other perfect squares.
Yeah.
Yeah. How do
So we really need to think about the list of perfect squares,
Yeah.
right?
List them
So
all out.
Babylonians didn't have Google, but we sure do.
List them
You
all
can just
perfect
search up.
squares.
Pythagorean.
Yeah, you can just look up a list of Pythagorean triples.
No, I can't.
Yeah, you can.
No, I can't.
I
I
won't.
tried. My computer said no.
Oh, okay. Okay.
Okay.
Good stuff.
Mm.
Whoa, that one. I like that one.
Which one?
The diagonal one.
Yeah, but that only goes up to like 15.
Yeah.
All right, so 196. Could we make 196 with two of these other numbers?
144 and 52.
But that's not a perfect square.
Wait, 169 and what would it be? 16? No.
I'm gonna try to find a bigger one.
Or you could just search a Pythagorean.
I can't.
Okay.
Yeah, the computer said no. Did you hear it?
Yeah.
Those are
Oh.
perfect squares.
That is not perfect square. That's square root chart.
Wait, the purple and green one.
Ooh, here we go. Squares 1 to 50.
But it's purple and green.
Did it have a lot? Okay, that's like taken at perspective. I'm not looking at that. Okay.
Well, I don't think you can ever add 1 to anything to get the next perfect square.
Wait. I need a calculator.
I had to do a lot of math yesterday.
I have to do a lot of stuff.
Why do you have to do? I had to do a lot of wrestling yesterday.
So here's the problem. The dilations of our other perfect squares don't count, quote unquote. So we've already, like, if we're thinking like short leg reference point, right? we've already got 6, 8, 10. We would already have 10. Ooh, 9 should come first, right? 9, 12, 15.
Wait, so both 5 and 9 work with 12. That's interesting. Yeah.
Different angles, right?
Oh yeah.
Which
Angle
creates different
side,
hypotenuses.
Wait, what angles work for those? That's what we
Angle
should-
I mean,
side.
we could do the trig.
We should
It's
do
that
the
thing- It's that
trigonometry.
thing with angle side side.
That's tomorrow.
Oh, okay,
Or
never
the
mind.
next lesson.
I never had that idea. Let's continue.
So then 10, 24, 26.
It's the difference. Wait,
Go back to
The difference-
picture.
wait. The different. Wait.
So wait, can we use
Wait.
4? We jumped over 4. What's 4 squared?
16.
16.
Wait, plus 9. Plus 3. No, wait, that's the same thing.
Wait, what are we trying to make? A perfect.
Other.
Okay, can you go back to the chart?
Yeah, go back to the chart. Thank you.
What comes after 16? 25 plus 9. Yeah, wait.
What?
That's just a backwards of the other one. We can't
Exactly,
do
that's what I
that.
just said.
Oh. Okay. Well then, no, we can't.
No, wait, I remember talking about one last year. Obviously can't remember. Oh, wait.
Wait, so hold up. The squares go from 1 to 4 is plus 3, from 4 to 9 is plus 5, from 9 to 16 is plus 7, and from 16 to 25 is plus 9.
What if we just grab all
I don't know if that helps
perfect
at all.
squares? Can we just
Like,
do
the
that? I
difference
feel like that would help me.
So
The
we
difference
skipped over
between
4.
squares.
We skipped over 4, but we seem to be getting stuck. We also skipped over 7 and 8. I would play with. Well, we haven't used 7 at all here.
I wanted
That's
to do
just seven's
7,
ugly.
so please go back to the chart.
Like,
Thank
seven
you.
squared is ugly.
You're up.
If you would just go back to the chart. So 7 squared would be 49.
Interesting.
So then we'd be working with a 49.
Anything that's a multiple of 10 squared ends in 0.
Oh, that makes sense, because if you square the 0, it doubles then.
It's useful to know. Wait, 29 and 7.
What do you mean 29 and 7?
They make 30. 29, 7, and 30.
So 880. Wait, 890?
No, they don't.
No, they don't. They almost do.
They
Almost.
I thought there was what I learned last year, but I don't remember it. Okay.
Why are you?
Because I'm mad I don't remember it.
Wait, can you go back?
What do you mean back?
Like, to the page that we have already figured things out. Okay, so
I
4
thought
and
you
5
wrote this
only have
down.
a difference of 1, and so did 12 and 13. So I feel like for the base ones, if we look at ones with differences of 1, that would work better.
Ooh, so what you're saying where the long leg is only 1 away from the hypotenuse?
Yeah, that seems.
That's a clever idea.
iCloud. Move your things to iCloud. Or actually, I think that's Google.
We're a Google district.
Google iCloud.
Google iPhone.
So wait, we want.
You have, like, Apple bought Google.
So like if
So
we were gonna
would
use
it-
if we were gonna use like 22 and 23, we need a short leg that when squared is the difference between 22 and 23.
31 and 32 are so close.
So we just really need to find what you're saying is we need to find this that is a difference of a perfect square.
Oh, yeah. Yeah.
That's what I'm just rephrasing what you said.
Yeah.
Hold up.
That is what I said.
Come again?
So what is the difference here? 29 plus 16, 30, 40, 45?
Wait, that is a perfect. Wait, no.
45 is not perfect.
Wait, what about go up one? Like 23 and 20. No. That's not.
Wait,
Here?
wait,
Yeah,
wait.
that kind of up in numbers.
Oh! I remember it! squared plus 24 squared equals 25 squared. I broke it.
Chill out.
Wait,
Hey, dude, you don't even know how excited I get when I'm teaching my other classes. So wait, 7,
That scared me.
7,
That's out of nowhere.
7, 24, 25. That is another Pythagorean triple that we can then dilate.
can we graph all the ones that
I am so proud of
We
They're all
can
prime
graph.
numbers. So far.
No,
Well, 25 is not a prime number.
neither's
Well,
24
no,
is
I
not
mean
prime.
the A column.
Ah.
not 6.
3.
So wait,
5,
challenge
7.
them. Challenge. If you're saying they're all prime numbers, I'm gonna pick one that's not. Wait, 10's not a prime number.
Neither is 6.
No, I mean the basic one.
10.
Okay, you can multiply anything by 2 and make it not a prime number. I mean the base ones, like the 7, the 5, and the 3.
Now you know what it's like to be a teacher. When you say something and kids are like, nah. So wait, but 8's not a prime number and it's not a dilation of
Yeah, it is. 6, 8.
8 is not a dilation of 6.
Yes, it is.
Well, no, it's a dilation of the 4, though.
But we didn't find anything that worked with a 4.
Yeah. Why would anything
So
work
I'm
with
talking
it?
about short leg, right? You can't talk about the 8 that we've used here
Okay.
or the 4 that we use there because those are the middle legs, right? The longer leg.
Can you go back to the chart, please?
8 is 64.
So now we want to find something with difference of 64.
Actually, before we do that, can we chart all of the pairs that we already have, like the 2 that are right next
You can do anything you want to do, but I keep writing stuff down and you keep not.
Come up to the 4th.
Can you? What do you mean? Can we like
I
circle?
mean, just like circle in the ones that we already have, like 4 and 5, and like
Well, okay. So
the basic ones here.
3, 4, and 5 got used.
Well, we don't.
What?
No, just not the 3, just the 4 and the 5, because the 4 and the 5 are the ones that have the one difference. The 3 is just weird.
You're just weird.
That's
No,
me.
I mean to like graph.
Okay,
it,
so
see what
this-
their relation.
This had a difference of 9, and that's why it worked.
Yeah.
This had a
There's 24.
this had a difference of 49, and that's why it worked.
And then we had one
Correct.
in the middle.
We should make like an equation for this if we can ever find out how to do one.
Oh my gosh, that's mean. I can't find one with 64. That's 63 and 65. I can't get
I think that's because it always alternates between odd and even.
I'm sad.
Yeah, it just
Shut up.
you can't find one because it just alternates between odd and even. 64 is an even number.
Are you only looking at the right side of this chart?
The what side?
Because you might be falling into the trap of thinking like all of them have to be
I
super big
know,
numbers.
but, like, that's true.
And do they have to be adjacent? Like 3, 4, 5, they were all adjacent, but like 5, 12, 13, okay, the 12 and the 13 were adjacent. But if we think about minimize. If we think about 6, 8, 10, these are not adjacent. I know that's a dilation, but like
What are you talking
10, 24, 26, this was not a dilation. Yeah, it was.
Yeah.
Talking about the long leg to the hypotenuse, are they always just one away from each other? Well, that works here. That works here. Wait, the one we just figured out was 8, what? Or no. Did we figure out 8? We figured out 7. 7, 24, 25. So these are still one away from each other. But like you said, we've only used prime numbers.
So if we use the
Now we're not using a prime number. I would encourage you look at B and C values that aren't just one away from each other. We're looking for 64,
two
right?
away from each other, yeah.
So like 49 to
Oh,
81.
it's
is-
15 and 17. I think. Yeah, 15 and 17.
You are correct.
So 8. Oh, you couldn't see when I was clicking around.
Yeah,
because
that's what I was gonna say.
that's what I was gonna say. But
Yeah,
I
if
didn't.
you look at the recording, I was gonna say something, but then I didn't say it.
Uh-huh.
No, you can look when he
No,
finishes the
yeah,
recording.
I heard you gonna say something.
Okay.
There is
I heard
one
you
more.
not saying something.
There is one more that I would like us to try and find, and we've already used this smallest leg but we only used it as a dilation of another
You
one.
wanna do 6, 9, or
9.
9.
I'm
Okay,
guessing.
9's
I'm guessing.
81.
So 9 is a difference of 81, right? So we need to find two of these that have a difference of 81.
Oh, 40 and 41.
40 and 41?
Yeah. 61.
Oh, 40 squared and 41 squared.
Would either of
I
you
wanna
like to
do
do this since
I
apparently
wanna
yesterday you
do
didn't realize it was happening?
Yeah, I would like to.
Wait, what? I see who did it.
Mr. Hall did it.
Yeah. Why is he standing
So
up
wait,
again?
40 and 41?
He's the
Oh, 1600, 1681. So you're saying 9, 40, and 41?
Yep.
You want to know what's funny? It's pretty much all of them.
Without dilating.
The Babylonians' tablet of hundreds and hundreds of these.
All for dilation.
I feel bad for them. They worked so hard.
No, there are more. They just get even more complicated.
These are the ones that you needed now.
Oh, you're such a small image.
Wow, I'm offended.
You're a small
Oh.
Oh my!
This is the visualization
Oh.
of Pythagorean triples.
Are each of the longer
Wow.
lines the ones that like start at the beginning?
Each of the heavy lines. Sorry. So this is right triangles. Right? But the heavy lines, I believe, are the Pythagorean triples. This is the problem with me not having planned out everything that I should. But most of, like, if you search up Pythagorean triples, you just start with the base and then you dilate from there and you start to kind of cover most of your options. There are computer programs that can run these things. So if we keep going, we can get 21, 28, 35, things like this. But then a lot of these end up being dilations of things we previously already solved. And because we only have like 1 minute left, this is pretty much everything we needed to cover. The main thing is keep your eyes open for things like this, where they've been dilated by the same scale factor, here being x. You can just factor, right? So this would be 5x. I mean, not necessarily.
You can ignore
Yeah.
it temporarily.
Yeah, you can use the factor as what you just used to solve your unknown.
Yeah, it's
So like 5, 12, we know this would be
13.
13x, right?
Oh, yeah.
And then we have some application problems
Hexagon.
that we won't get to because it's time for you guys to go to lunch if you want to.
So do we do
And that's it.
6.1, 2, or?
So, our critical problems here. I didn't make it this far because then I got busy hanging up. I want you to do 20 because you might not know how to do these problems yet. Hopefully you remember how to do them.
I love those puzzles.
I remember those. Those were easy.
Whoa. 20, 21.
They were easy, simple, electronically simple. That's 7 homeworks.
That's 6.
It's 6.
Oh, it is.
Way to make your math teacher feel bad.
Oh, yeah, you're right. It's
And 23.
Oh, that's,
Now it's
20, 21, 23 since Connor said they wanted 7.
I did say Connor, you're twisting my words.
I am 100% twisting your words.
You also gaslighted us saying that you never say that we're your favorite class.
I don't even really know what
I
gaslighting
don't think
means.
Gaslighting means is
They
like you
someone
lie
thinks that
about
they have false memories. Have you ever seen the movie Gaslight?
Probably not.
Yeah.
Then he wouldn't have
I've never seen it.
I don't remember having seen it. Is that
It's a
funny?
movie where, like, someone's like told
gaslighting people.
that something happened, that something didn't happen to happen.
Bye, guys. Have a wonderful
Yeah,
day.
exactly.